Okay, so this lecture is a little bit different compared to others because we're kind of going to reveal some things that we have been talking about and fill in some gaps instead of just all new material necessarily. So we've been talking about one-dimensional vectors. We've been saying the term vector a bit. And so this is what we make when we use our combine function. And we can have a variety of different types of classes for vectors. We could have characters, which we've talked about, character strings. So that could be something like, I don't know, a list of animals, right? It could be numeric. We've also talked about something like this. And there are a couple types of numeric classes. There's integers, which have whole numbers. And then there's double, which stands for double precision. And so there's fractional values for those. We'll go over this a little bit more. We're also going to talk about factors a little bit. We'll have a whole module about it. Logical, which is true or false values. And we'll go over a little bit about dates and times. All right, so like I said, we've already talked a little bit about character and numeric classes. If we wanted to check the class of something, we've also already done this. We can use the class function to check. We're going to see why it matters a bit more now. So here we can see that this is numeric, as we would expect. And if we had done character strings, we would get character. So what happens if we mix things up and we have characters and numeric? It will by default assume character. And that's because numeric values can actually be character values. And at first this might seem a little strange, but this is true because we could have a factor, for example, which we'll talk more about what that means. But there are cases where we might have a numeric value where we don't necessarily mean the value of the number, but we might be talking about levels of something, like maybe levels of a game. How many people got to level 7 of a game, for example. And then logical data are those that are either true or false. And it's very important that when we create logical data, we don't put any quotes on it. So if I do it without quotes, R interprets it as logical. If I put quotes, then it looks like a character string because this is what R is used to seeing when it gets character strings. And so you see here that the class is character. So just like if this were other strings, they're in quotes. So it's very important that if you do want R to think of something as logical, don't put quotes. All right, sometimes we need to tell R that we want to change the type of data to a different type. And we can do that with a variety of functions that have to do with the type of data that we're trying to coerce the data to be. So for example, we might have something that's being interpreted as character. Maybe when we imported the data, it looked like character. I got that error because my second quote was missing. But say we don't want that. We want this to be numeric. You know, this is a case where we might want to convert that. And so all of these are named pretty self-explanatory, wise. We got as dot numeric, as dot logical. Date's a little bit funky, it's got a capital D. As factors a little bit different, there's a few ways to make factors, but again, we'll have a lot more discussion about that. You can't do that, but you can put that into a factor, which again, we'll have a whole module about that. Yeah, so this is how we would check. We'd use the class function, just like we've been showing. But to coerce here, I can use as numeric if I have values that can be coerced, like we talked about. So let's change this to as numeric. And we'll say we need to reassign it, right? Otherwise, it's just going to stay as character. And take a look at the class. All right, we converted it to numeric. Indeed, if the question asked character, it's going to say that we got NaN values or NA values for this. So if we take a look at X, we have 2 NA values. So that's what happens when you try to coerce something like that. For our data where we have true and false, if we forgot and we put quotes around them or they were somehow imported with that, we can just simply do as logical and convert it to being the logical class. And this is just saying that this is the 0 can be considered false and true can be considered 1. So we could do something like this, and we could convert it to logical. That's a special case. So if I did something like this, it's not 0, so it'll be considered true, but the characteristic or the conventional way of doing numeric logicals would be 0s and 1s. So best to stick to that. But sometimes you'll see your data coded like that. So sometimes, like we already saw, when we try to coerce, it doesn't work quite like maybe we'd hope. And so it's actually potentially a good thing because sometimes we want to produce NA values. And so again, if we try to coerce something that can't be, it will be coerced into an NA value. And it will typically give us a warning, which is good, so that we know that something like that's happening. So this is great for here example. We have for this example, we have true, false, and unknown. And we probably would want unknown to become NA, but we certainly want to check our data and see if that's what we actually want. Here you can see using as date, we get an NA value for this date. Can anyone tell me why we get an NA value for that?
Because of 32.
Yeah, that date doesn't exist. And that's helpful too, right? If you had date values that were coded incorrectly, it's kind of nice for R to be like, no. And then you could go back and think, oh, that's maybe the 31st, or maybe it was the next month, try to figure out maybe what happened there. Okay, so recall that there are a couple of different types of numeric classes. So I discussed this double and integer. Talk about this a little bit more. So double is what stands for double precision, and we've seen this in our tibbles a bit. So I say, oops. Remember, Iris is a data set within R. So if I just say tibble here, I see that my numeric values here say double. And here I see that this is a factor. So they're just abbreviated here. So does this make sense? Should these be double? Yes, they should be, because they have fractional values. So they're more precise than an integer, which would just be the single value. So if we wanted to know how R was interpreting that, we would use the type of function. Or we can take a look at it as a tibble, and it tells us one of the nice things about tibbles. If we didn't want our data to be double precision, we could change it to integer. And to do that, we can use the as integer function. And here you'll see that it converts it to the nearest integer without rounding. If you wanted to round, you could use a function called round. So that might be more, that's likely more like what you'd want to do. And so if we had values like this, we say, oops, no underscore. This is double currently, and we want to make it into integer. I'm going to say as integer. And I'm going to reassign that because I actually want to change my data. And then I'm going to check the type again. I've now converted it to integer. And if I take a look at X, I see that it's converted to just 1. Again, the round function is also nice. I can specify the number of digits with an argument called digits, and I can say 2 if I wanted to keep this, say this was something like that. It's going to be the number of digits after the decimal. So let's add a couple more digits or another digit just to show this. And see that it has rounded. This is 5, 6, so it becomes 6. Becomes 5. How you might expect. And so those would stay as double precision though. All right, so we already walked through this, but if we had integer value and we checked it, if we wanted to create something with integers, we need to use as integer. You can also create them using some functions called seek and sample, and that's if you're sort of creating synthetic data. Otherwise, they're going to be double by default. So when we put in number lists like this, even though these are integers, you can see that the type is double. So if you end up creating some synthetic data using seek and sample, you'll see that that's the case. Actually not going to go over this because I don't want to spend too much time, but synthetic data is something that can be useful. So if that's something that interests you, check those out. All right. And so again, when we look at our tibbles, we get a little bit of a preview of what the class is for each of our variables. So we've already seen double, and we saw character or factor for our iris data for the species value or variable. And here we're seeing int for integer for any variables that are integer class. So that's why it's really nice to see that, because if our data is getting evaluated in a way that is surprising to us, it's useful to be able to check the class without having to type it in. If we use glimpse on our data, remember that's the function that sort of creates the sideways version or view of our data. But then we also get these abbreviations just like we get with our tibble. So as an example, with our iris data, now it's turned to the side, what we just saw, and we can see our double and our factor. Factors. Factors are special character vectors. That makes sense. These are characters that have predefined levels. So there's some extra important meaning behind what those character strings are. And so we can sort of think of these as qualitative or categorical variables. So some examples here are, I think a really good one is different ages, different age groups that have a sequential meaning, or the level of how much somebody agreed to something in a survey. And we'll talk in much more length about these. Okay, so if you wanted to create these, you can use the factor function. So here we have a character string. There's a bunch of different character strings. If we look at the class, it says that it's character. So R doesn't automatically know that small, medium, and large has some sort of significance. R is smart, but it's not that smart, which is good because we can specify, right? Because maybe small, medium, large, in some instances, we want it to just think it's a value. And so it's nice that we have the opportunity to decide with coercion of making this a factor. And in this case, we just use the factor function. This is the special case. We don't use as dot factor, but just factor. And we can create this, coerce this into being a factor. And now when we check the class, we see that it's changed to a factor and it has these levels. The levels will automatically be in alphabetical order. So we have large first, medium, and then small, which is probably not what you want. We're going to talk about that in the future, how we change that. So why can't we just use as dot factor like we've been using for everything else? You can, but you can't specify levels. So that's why we're suggesting use factor without the as. But again, we'll talk about that more. If we wanted to specify levels or check the levels, excuse me, we can use a function called levels. So here in the iris data, I already have a factor. So I could ask, what are the levels of species? I'm gonna have to. So let's get rid of this so you can see it a little bit better. It's telling us that these are the levels. I'm not sure why we would have levels for different species of flowers, but maybe there's some significance that the person who created the data knows. Seems likely in this case, we'd want them to be character, so we'd probably coerce it back to being character. And the way we would do that is with as character. Just like this. And when we have a tibble, we're going to want to do that within our mutate function. All right, so a little summary here. If we have a value like this, that's numeric, but of class double because we have fractional values. If we have a value like 1, it could be integer or it could be double, so we'd have to check. If we wanted to coerce a value from 1.1 to 1, we'd want to use as integer. If we create random data using sample or seek, sample is random, seek is a sequence, be sequential. It's going to by default give us integers. These are character values. Character values always have quotes. It's very important that they have quotes. If we want to make logical data, we only use true and false. We do not use quotes. For factors, there's some sort of significance behind the character values, and we want to use factor to create those. All right. Okay, so there are two types of numeric classes, integer and double. Everything else is a little bit more straightforward. Logic, though, can get a little tricky because we don't want to have quotes. You can use the class function to test out what the class is. And we can typically use as dot whatever the class is to coerce or change the object into that specific class. However, factors are different. We want to use the factor function. But we'll talk more about factors later. And tibbles are great because they give you a preview of what the classes are. Well, now we're going to talk about two-dimensional data classes, which you're probably not going to need to do too much with, but if you want to do things that are fancy in terms of beyond the data frame, which of course we've talked about, perhaps you'll be interested in reading in multiple data files together and working across those data files. So we're going to briefly talk about it. Okay, so we've talked about our single dimension vectors. Now we're talking about two-dimensional data classes. So it could be something that has rows and columns, or could be more dimensions. But so far, rows and columns is what we've been thinking about. And we've been talking about data frames and tibbles. There's another form called a matrix, and you might run into these. They can be really helpful if you want to do linear algebra or certain tasks. The difference with these is that they are entirely composed of one data type. So they're either all going to be numeric or they're all going to be character. And so we create a matrix using the as matrix function, similar to our other class coercion functions. So here we have our iris data set. Here I'm just showing the first 3 lines. But here, if I wanted to show more of it, just type it all in. You can see that there's a lot of different values for these various numeric measurements of different iris species. And we have, remember, that factor variable called species. So if we were to make a matrix, we'd have to remove the species variable because we would need all the variables to be of the same class. And a little reminder that we can remove columns using our select function and the minus sign, or we could select where is numeric, or we could select where it contains sepal and petal, a bunch of different ways. But this way makes a lot of sense. It's quite simple. And then we could convert that to a matrix. So here we see the matrix output, and it looks just slightly different. We can see that sort of the indication for the start of the row is slightly different compared to the data frame version. So just showing that over here, I'm going to prepare the data. I'm going to select where we don't have the species column because it is character. And I'm going to put that into matrix. Go directly. Oops. All right, so not too different looking here. If I wanted to create one from scratch, I can use the matrix function, pretty well named appropriately. So here I'm making a matrix out of the values from 1 to 6, and I can tell it the number of columns that I'd like to make. And so I'm telling it that I want 2 columns, and so it splits the data up evenly with the first 3 values in the first column and the second 3 values in the second column. Probably not often going to be creating them from scratch, but possibly. Another variable or data type to know about is lists. And this is when it can be really helpful if we're working with lots of file types or lots of different files, perhaps, and reading in multiple data sets together. And this happens when maybe we're analyzing survey data across years or something like that. But the cool thing is lists don't just have to have the same data type. So often it is useful, though, in public health to have the same data type. So that example of survey data, you might have a list of data frames, but you could actually have data frames. You could have vectors, you could have matrices, you could have models, all sorts of things. And they can be really useful because you can repeat processes across them multiple times. And we'll talk more about that when we get into functions. We create them with a function called list, also appropriately named. So here I'm showing how you can create something with a variety of different data types within the list. So we can have a vector, this is a character vector, a numeric vector, and a matrix. So we're just creating a matrix from scratch. And we use the list function around all of this to create our list. And you can see that we have these sort of like bracket values that show us where the components are within our list. And so with our matrix or matrices, we'll see, little commas that kind of indicates that we have a matrix there. But overall, the class of our list is list.
Harry or Ava, have either of you ever used like genomic or genetic data that's in a matrix?
Yes.
Yeah.
Yeah, gene counts, like if I'm looking at RNA-seq or something, it's usually in a matrix. So let me go back here. I wanted to demonstrate some of this. So let's try creating a list. So let's create a matrix, and we're gonna just have 4 values, and I can specify the number of columns or the number of rows when I create a matrix. So in this case, I'm gonna say 2 rows, let's say 2 columns. And then I'm going to create, I don't need this C up here. A vector that's numeric. And I want to assign this to something. We have a parentheses error. I think I have an extra. Yep. Okay. So we can see that we have a list because we've got these funky little bracket things here. And so when we have a double bracket, it's indicating where the elements of our list are. And so we have our matrix and our vector. But it's kind of useful to name these, can make it a little more clear what's going on. And so I can instead say, an element, the name equals whatever it is that I'm putting inside. There's another name, another element, and then I will have an output with a $sign. So here I have a vector that's the characters, letters, called it letters. So here I see that vector here in the first element of the list. Second element is the vector with numbers. And the third element is our matrix. And so I could show that here. I'm going to call this matrix example. I'm going to call this numbers. I'm going to make it look a little prettier because it's kind of hard to read right now. That looks better, right? And I can really see where my parentheses are if I do that. All right, now the output is much more clear what's happening. I have a matrix and a vector. But you could see maybe you'd have multiple data frames. I could do something like So here I'm putting in the same data frame twice. I'm naming it two different things. And in my data frame, or in my list, I can see that I have, it'll just show me the elements are called iris1 and iris2, and it's going to give me the output of the data frame because they're quite large, unlike my first version where I actually printed it out together. All right, so that's a little bit of an advanced topic, but we just wanted you to know in case that's something that you do a lot of in terms of working with multiple data files at the same time. Again, we'll get more into that later. So this lecture has a lot of preview lectures or previews to future lectures. So we're trying to get you excited. All right, a little bit about special data classes. We know that some of you work with date data, and there are a couple of common data types. So we talked about the date class. That's typically for a calendar date, but there's also something called POSIX CT, which represents a calendar date, but with also, in addition, time, and it'll have it in hours, minutes, and seconds. And we can convert between those depending on what we want. There's a really powerful package, part of the tidyverse, called lubridate, and that can enable us to really effectively work with dates. Not everyone needs to work with dates, so we're just going to preview it a little bit, but if you want to learn more, check out the lubridate package. So here's some examples. So here, if we type in a date, R doesn't necessarily know that it's a date, just like it didn't know when something was a factor with specific levels. We have to tell it that we want it to be treated that way. So we could load the lubridate package. You're already loaded the tidyverse, so you don't necessarily need to do this, but say you were just using lubridate, you would need to load it after, for your particular markdown file or something. And there's a function called year, month, day, or YMD. And that can help us to convert this to a date. Specifically, it needs to be in the format of year, then month, then day. Otherwise, it will cause a problem. So then when we use this on this character string and we check the class, we can see that it's been converted to a date. So now R thinks that this should be interpreted as a date. So an example here. Let's just do today's date as proof. It thinks it doesn't even know, even though it's today, that it's a date. That's in year, month, day. As you saw when I typed this in, if I hesitate, I'll do that again. I can see that there's a lot of other options. So I could have hours, I could have minutes, I could have hours, minutes, seconds. I could do month, day, year. So there are a variety of ways to do this. Year, month, day is fairly typical, and it's what we want in the way that our date was formatted. So let's use that. I'm going to just copy paste this. And we'll take a look at class here again. And now we've converted it to a date. Why is this useful? This is why. So if R thinks it's a date and not just some random string of numbers and dashes, then it can do really nifty things for us, like find the difference between two dates. So here we can see that this is 3 days apart by subtracting B from A. So it's really useful if you need to do that sort of thing with your data. So again, dates are kind of tricky. There's a function called date itself. I'm going to do this in the console. I can't see though because the controls are in the way from Zoom. Oh, still on the way. Okay. Oops. Let's put my YAML there. If I type in date, there's a function within looper date. There's also, like we previously saw, if I do capital date, there's also one, I guess, in looper date as well, but there's a base R version that we were showing earlier. But date is really picky. It doesn't like here that we have slashes. It wants dashes. So, you know, this worked, but this doesn't. So you have to have it exactly formatted in the way that it expects. So we could, you know, replace these values, which we'll be showing you how you can do that sort of thing in the next lecture, so that you can get it into the style that you want. So here we have to have it in months, day, year format for it to actually be appropriately recognized. So I think it's easiest to just stick to these more specific functions where it's month, day, year, month, day, hour, underscore hour, etc., and avoid the date functions because it's a little bit like, well, what is the default? How am I supposed to have it? I know exactly how I'm supposed to have month, day, year. I'm supposed to have month first, then day, then year. All right, but then we talked about the POSIX CT class. So sometimes we have times and a timestamp can be really important. And so similarly, we just need to have it appropriately for whatever type of timestamp we have. So if we have all the way to hours, minutes, seconds, then we would need to use, you know, either month, day, year, or YMD, depending on how our date is formatted, underscore HMS or H or HM, depending on what we have. So you just need to pay attention and use the right looper date function is basically the takeaway. All right, so this lecture is basically just pointing out that there are some things that you could encounter depending on the type of work that you do. So we've talked about our two-dimensional data frames. We have data frames in tables and matrices. They have rows and columns. We have lists, which can actually be multi-dimensional beyond two-dimensional, right? We could have a bunch of things. Matrices have columns and rows, just like a data frame. The difference is that they're all one data class, which is really helpful for certain mathematical operations that we might be trying to do. And we can create those by coercing a data frame using as.matrix, or we can create them from scratch using matrix. We can create lists using the list function. If we're interested in using dates or dates and times, it's quite helpful to use the lubridate package. I suggest that you kind of avoid the date, and then there's uppercase and lowercase functions, and just stick to the specific date style function that is appropriate for whatever data you have. So either year, month, day, year, there's a bunch more, or the specific one for if you also have time information. It is for how the data is. Yeah, it's for how the data is so that R understands what we're trying to work with and convert that to being recognized as a date so that we can do nifty things like this. All right, so that is the end of our class module. So we're going to jump into our next lab.